Good afternoon, students. I'll start with the class. So we'll continue with the implicit type of questions. Next question is find dy by dx. If x raised to y is equal to y raised to x, find dy by dx. So this type involves both x as well as y terms. And then you know that it's like function raised to function. So to get rid of it, you'll have to take log on both the sides. So whenever you take log, it will look like this first. Then this power will come out. And then you differentiate. Both the side, this will be u into v, again this will be u into v. So u into derivative of v, that is 1 by x, plus v into derivative of y will be anyways 1, but extra, because this is derivative of y, we are differentiating always with respect to x. So that's why it will be extra dy by dx. Now u into derivative of v, derivative of log y is what? 1 upon y, but then extra I'll have to write dy by dx, plus log y into derivative of x is anyways 1. If it is the same letter you are differentiating it with respect to, then no need to write anything extra. Then bring the dy by dx terms on one side, take the remaining terms on the other side. Log x, this one, and this term taking on the other side. And then you remove dy by dx common. Whether you want to write in front or this side doesn't matter. And now you cross multiply. And then keep dy by dx here only and take the remaining terms on the other side. So dy by dx will be y is at the denominator here. So when you take it on the other side, it will go to the numerator. And this whole term will come to the denominator because here it is multiplication. So this will be our answer. Next question. This is into, okay? Any number you can, any constant. Okay, even a could be there. Suppose if I consider it to be 10. Find dy by dx at x is equal to 1. Can anyone tell me what will be the first step? What will be the first step the moment you see function raised to function?
Log.
Yes, you have to take log. So when you take log on both sides, then will I differentiate directly? No, because this is complicated. Both are functions, still it's not got right. So can anyone tell me what will happen now? Which formula to use here?
Log A into B.
Yes, log A into B formula. So that will be log of A plus log of B. So this will get separated out. And then always bring the power out. Now it got simplified. Then you can differentiate. Again, now this is turned out similar to the previous problem. U into V. Again, U into V. And derivative of log 10 will be anyway 0 because log of 10 is a pure number. So whether there is a 10 here, 20 here, doesn't matter, or even A or B, any letter also, still derivative of that part will become 0. So differentiate and then keep dy by dx terms together. Remaining terms you take on the other side. So once you differentiate, it will be log x into dy by dx plus, this was about these two terms for this, u into derivative of v plus v into derivative of u. Then this x into 1 by y dy by dx plus log y into 1 is equal to 0. That last part is 0. Same way, keep dy by dx terms together and take out dy by dx common. Remaining terms you take on the other side. So I will skip a step and straight away take out dy by dx common. So minus y by x minus log y. These two terms kept here, this and this one, took it on the other side. Now I can cross multiply. Minus, if you want, you can keep common. So what it will be? Plus. This will go up here. This is only if dy by dx was asked here, this would have been the answer. But now it's asked at x is, what has been told, at 1. Okay, both x comma y. Just if I've given only x is equal to 1 at x comma both the places. Okay. At x is equal to 1, y is equal to 1. So put both everywhere 1. So dy by dx will be again 1 into log 1. You know that log of 1 is 0. So overall 1 plus 0 will be anyways. So dy by dx will be minus 1. And the last one on the implicit function. Because of the time limit, I cannot solve each and every problem. So that's your duty now to refer your notebook again for many other problems. Cannot stick to only this. Because if I go to repeat each and every problem, 1 more year it will take. One second. X root of 1 plus y root of 1 plus x is equal to 0. Okay, so sometimes instead of 1, this could be 2 also, could be 3 also. Okay, this number could change inside. I've already done for you all with this as 2. Okay, this is slightly different. That's why I'm doing this again. Don't directly go to differentiate, okay, straight away. It will get complicated because there's a root sign. So for that, what we'll do is, we'll first get rid of that root sign. When I take this, it will become minus. And in order to get rid of the root sign, you can square on both the sides. So whenever you're squaring, be careful, this will anyways become square and root and square will cancel, just become this much. Anyways, minus y the whole square is anyways plus y, and okay, it's like squaring both the terms. Square and root will cancel. This one's square will remain because this is not root. Now, what you can do is try to bring the terms this in such a way that y remains on one side. Okay, so just open up the bracket. Bring the pure terms on one side, means x square and y square this side, and this one you take on the other side. Whatever is common here, you take out common. So what is common? X and y is common. So from here, x is gone. So this will become y minus x. One x I took out and one y I took out. So only here y will remain, here x will remain. Now a square minus b square can be written as a minus b into a plus b. Now the thing is, I cannot straight away cancel these two terms because they are opposite. This is x minus y and this is y minus x. So before cancelling, I'll make it same like this one. So you can make it reverse by taking out minus common. So whenever you take out minus common, it will reverse. And now you can cancel it with this one. Okay. So next step, x plus y is equal to, I want y single on one side. So take it on the other side. Oh no, y will have to bring out common now, beta. Y terms, I want a single y. So this I'll have to take on the other side. I want a single y out. So that I can find dy by dx. So what is common over here? Y is minus y is common. Or x plus 1, whichever way. So what is the value of y? Nothing but this will give you, it's like instead of writing at the denominator, I wrote it up. So I kept y single here, this one will come with the denominator. And now you differentiate to find dy by dx. Now it is in which form? U upon v rule. U upon v. So what is the formula for u upon v? V into derivative of u. This is v. Derivative of u will be minus 1. Middle sign is minus. Then u is how much? Minus x into derivative of v upon v square. Then open up the bracket and solve. Minus into minus will give me plus. So your answer is minus 1 upon 1 plus x plus 1 the whole square. Okay, so this is about implicit functions. You want to higher order derivatives. So you know that whenever y is equal to f of x, when you differentiate it for the first time, you will have to write it as dy by dx, which is also same as f dash of x. First time you are taking a derivative. And whenever you are taking one more time, that will be, so up till second order we have. Okay, higher order means 2 times we'll have to differentiate. There is no way you will find this with cube and all. 3 times. That's only for if many this 1 mark question and all. But other than that, big problems you will have only till second. So this is also called as y1 sometimes, and this is also known as y2. Here, not up. Your subscript you have to put, that is here, which is same as d square y upon dx square. So 2 times if you differentiate, this way you have to write. Not d square x. If you put d square x, they'll cut marks. Here it is d square y upon dx square. Instead of m, it could be any pure number also. They can put it as 2, 5, 10, doesn't matter. M is like a constant. So you have to take this. Now you definitely look over here and see, you know that you have to differentiate it 2 times because the highest order here is square. So take the first equation, whatever they have given, differentiate it for the first time. So when you differentiate, either you can write it as y1 or dy by dx, however you all are comfortable. I have done problems in both ways on the notebook, with y1 also and dy by dx. Now when I'm differentiating, this is e raised to something. So it's like in the form of e raised to x. So derivative of e raised to x is e raised to x only. Same thing, but with extra derivative of this. M is like a pure number, so it will remain there only. And derivative of cos inverse x is 1 upon root of minus 1 upon. This is m into. If it was 5, this would have been 5 into. Okay, some of the teachers will directly take root decide and differentiate. You can do that also, okay, by taking root sign also, but I prefer using that method where I have to square it. Okay, before doing that, if you have seen, the same thing has come up again. Okay, so instead of this, I can put y here back. So overall, what it will become? Like this. You can mark this as 1 and you can write from 1 I got. And now to get rid of this root sign, because I don't want to deal with root by differentiating again, it becomes a confusion. So I just square on both the sides. If it was tan inverse, no, over here, then what it would have been? Just 1 upon 1 plus x square. If there is no root sign, then there's no need of squaring. Only if there's a root sign, you have to square. For tan inverse and all, you don't have to square. When you square, you will get like this, dy upon dx, the whole square, m square, y square. Anyways, minus 1 upon that will be plus 1. So square, when you go, it will become just 1 minus x. Now take this side. This denominator will go up and get multiplied to this. Okay. And now you differentiate. Second time. So while differentiating, this will be u, and this will be v. U into derivative of v. So first we'll write simply u. Now over here, this is in the form of x square first, something square. So what is derivative of this? This you have to assume as x. X square will be first 2x. Okay, derivative of x will be 2x. Then into extra derivative of this. So when you differentiate it for the second time, it will become d square y upon dx square plus v into derivative of u. So that will be 0 minus 2x is equal to m square. This derivative of y square will be 2y extra dy by dx. Okay. So if you want, you can write nicely first. Simplify. So just writing this side. Then minus overall 2x dy upon dx the whole square is equal to 2m square y dy by dx. After doing all this, now check what is common everywhere. So if you notice, everywhere in the equation 2 dy by dx is common. Again here, see 2 dy by dx. Here 2 dy by dx. So divide throughout by 2 dy by dx. So from out of the square, 1 dy by dx will go and only 1 will remain. And whenever they ask you to prove something, you know that whatever you should get, somehow bring it up to your final answer, whatever they have asked for. So 2 dy by dx is gone. So what remains is, again here 2, 1 dy by dx is gone. So only out of square, only 1 will remain. 2 and dy by dx is gone. So only m square y remains. And that's what has been asked. So like the same way, if you have with sine inverse of x also, same way you have to follow, same answer you will get. I've done with tan inverse also. Okay, can check your notebook. Before that, I'll do this. Prove that okay. Will you all directly differentiate this, or how will you use this? Simplify this, you all can tell me. Root, whenever there's a log and a root, what can be done? Hmm?
Substitution of cos.
No.
Raised to
Substitution of this is log, that is no any other. This is not cos inverse, so that your cos 10 and cos will cancel out. Log, you can just see in which form it is, no?
raised to half.
Yes. So this root has to be written as raised to half. Okay. Raised to half, then half will come out this side. Then it will be in the form of log of a upon b, which can be separated out as a minus b. Yesterday only I told you, if it looks complicated, always you can separate out by using a. And substitution, when it will be something like this is there. And then when you substitute something and then it comes out as 10 and then it cancels. Because even if you substitute something, log and something will never cancel out. So you know that it is definitely not substitution. It will look like this first. Then this half will come out. And straight away, so that I don't waste time in writing one more step, this is in the form of a upon b. So that will be, half will be anyways common for both the terms. So log of a minus log of b. And now you differentiate. Because straight away you know that log of this will be 1 upon x. Okay, after differentiating, keep this will be anyways 1 upon 1 plus x square. This will be 1 upon x minus 1. This will be 1 upon x plus 1. And then cross multiply among itself. This answer and this answer, you cross multiply. Then again you can cross multiply with this one's answer. So y is tan inverse of x. Sorry, this after differentiating, this will be dy by dx. derivative of tan inverse of x will be 1 upon 1 plus x square, half out 1 plus x minus 1, derivative of this, that is, even if you try to multiply by derivative of this, anyways derivative of x will be 1, so there is no point. If it was 2x minus 1, then this would have been 2x minus 1 into 2, but now this is a simple x, so that's why it will be anyways 1. And now you cross multiply. Minus x, minus of minus will become plus, and a plus b into a minus b will be a square minus b square. A minus b into a plus b. One by two. This will be 2, no? 1 plus 1 will be 2. 2 and 2 will cancel. And now what you do? Again you cross multiply. Okay, and then instead of writing 1 plus x square, write it as x square plus 1. So what you will get? Dy by dx will be 2x square upon a, again a plus b into a minus b will be a square minus b square. A square means x square, the whole square will become x raised to 4. And now what you can do, take this denominator, yeah, and then differentiate it for the second time. U into v rule. So u into derivative of v, that will be v square y upon dx square, then plus v into derivative of u, that is 4x cube, and means derivative of minus will be 0. This will be 4x, and that's what has been asked. Okay, 4x cube divided by is equal to 4x. Okay, here tan of something. Okay, so it will become complicated if you see. If you directly go to differentiate, this will be 1. This will be tan of something will be again sec square of 1 by a log y into again something into 1 by y into dy by dx, and then it will be stuck. Okay, so it will get complicated in this. So whenever there's something very complicated inside a tan, or this could have been sine also, okay, any other trigonometric function, if it is there and there's a log inside, what you do is normally take this tan on the other side. So whenever you're taking this side, it will become tan inverse of x. Then you differentiate. So this is the thing given. Take this on this side. Either you want, you can take a also this side, no problem. You can keep it there also, no issues. And then now it's become simple c. There's no u into v. Straight away now you can differentiate with respect to x. So 1 upon 1 by a is anyways coefficient, so that will not make any issues. Derivative of 1 by log y is 1 upon y extra dy by dx. If you see who is there along with this, look at the answer. D square y upon dx square, the side there is 1 plus x square. So you know that what should have been there whenever you apply next. This is usually at the side of this velocity, but here it is at the denominator. So what you do before starting to differentiate, take this up. Okay, try to avoid any denominators. So this you can take up and this you can take here. A y will be equal to 1 plus x square or x square plus 1, whichever way. And now you differentiate. This will be u into v. So again, when you differentiate with respect to x, a is a coefficient. Derivative of y is anyways 1, or straight away you can write dy by dx instead of 1. Derivative of y is dy by dx. This is u into v. Derivative of dy by dx is d square. And then v into u. Now bring dy by dx term on the other side. And then take out dy by dx common. And then you will get the answer if you take dy by dx common. Suppose instead of this it was sine inverse, suppose. Okay, then what you would have got here, root you would have got. So if you want, you could solve along with the root only, no problem, or else you could have squared it up. And then same one with sine also I have done in your notebook, you can check. So whenever there's a root, I have squared it. Last one on this. Now just because I said if there is something log inside, take it on the other side, don't make it as log inverse y and keep. You all can do anything. Only if it's a trigonometric function, you have to take it on the other side and solve. Yeah, what there's no choice. You have to directly differentiate it. Prove that. Okay. So take the first equation, differentiate it for the first time. Return this is something. The whole square is there. If you all are solving simultaneously, then the revision is helpful. Huh? Otherwise, if you are simply sitting and watching this, it's of no use. It's waste of 1.5 hours. But if you're actually solving simultaneously, most of your revision, at least you have the idea now. At least so many problems will be done now in 1.5 hours. If you all sit alone, I don't think so. Some 2 questions only all must be solving. When you differentiate, log of this is like x. So log of something is 1 upon that into extra derivative of this. Okay. So I don't want like u upon u 1 upon u into v. Is complicated things. And if you take all 3 terms on this side also, it will become u v w. Okay. So I don't want that. So what I'll do, I'll take only one of the terms there. X dy by dx and do this. Log x I'll keep here. You can try various ways, whichever way. Then only thing it might get complicated, but once you start solving and substituting, you will get the answer. Okay, now you can differentiate it for the second time. Now this is u into v, and this will be u upon v, or straight away 1 by x formula I can apply. So u into v plus v into u, derivative of x will be 1, is equal to derivative of 1 by x is what? Minus 1 by x square. Either you can straight away use this formula, or you can use that u upon v rule. So that will be what? V into derivative of u. U is what? 1. So that will be anyway 0 minus u into derivative of v upon. Anyways, it will be like 0 minus 1. It's like this. We'll get. If nothing, if you reverse this, it will come back here only. This if you take, so straight away I'm writing that. Okay, actually your answer, this is done. You cannot do anything more than this. If you go to differentiate one more time, what will happen is, you know that one more time if you differentiate, it will become cube. But now this is not what has been asked. Okay, if they are not asked to prove anything, this would have been a final answer. But there's something, x dy upon dx the whole square is missing this term. So I have to try to arrange this term in this form because this term is there already. If you see the answer, what has been asked to prove, x d square y upon dx square plus dy by dx. Okay, plus. Anyways, if you bring it this side, it will become plus and x dy. This is there. So this term is already there. This term is also there. Only this term we'll have to adjust in terms of dy by dx. So check in your this question only what you had got. Your dy by dx is 1 by x log x. This is what you had got. So just put there 1 over there. Equation 1 where you had got dy by dx is 1 upon x log x. Now I want it as square. So if I had squared this, what I would have got? This also square, this also would have become square. But what is missing here? Only one x is there. One more x I want. So I'll just balance out with one more x. So that this becomes x square. Now x into x is x square log x square. And this is nothing but your dy by dx, the whole square. And then bring this term this side, again equate it to 0. So you got your answer. And if you want, you write from 1. Bring it this side, make it plus. We'll move on to the parametric type. Parametric means x will be given to you separately, y will be given to you separately in terms of either t. Okay, this also will be in terms of t or theta, or it could be something m. Okay, where m will not be a constant and it will be some variable. Okay, and then you have to find dy by dx. So for parametric, dy by dx will be dy upon dt. First we'll have to separately differentiate with respect to t, both the places. And then y answer upon x. Please do not do x upon y, it will be wrong because dy by dx. So y term first, then x. So this will be the formula for parametric. First differentiate separately with respect to whichever variable they give. If it is theta, it will be theta over here. First one. Find dy by dx. So you know that your variable is t. So first find dx upon dt, then find dy by dt. And if they are giving you at some t is equal to some value, then only thing t value you have to substitute at the end after putting. Okay. Not at the starting. Suppose if they had given at t is equal to 1, don't put t is equal to 1 first only. You'll get answer dx upon dt as 0 then. Only after finding, then you have to substitute. So first
4 into 2t square minus 5 upon 3 into t square plus 1.
into you're getting the denominator. Okay. So t, this is like x the whole cube. First it will be like this. X cube will be 3x square into extra derivative of what is the inside. So this is 6t upon same way dy upon dt, that is again this is in the form of x square. Derivative of x square will be 2x into extra derivative of what is inside the bracket. So that will be 4t, and this derivative of 5 will be 0. 8 and dy upon dx will be, write this formula, second thing upon first. And if that side as t is equal to 1, then you have to put t as 1. T and t will anyways cancel. And this also, that will be answer. Second one, these are from the recent question papers. That's why I mean. If your teachers are asking you to refer this question papers, all the solutions will be there in the notebook because I've solved all the question papers. The question papers are already sent in the group. Now at least time being you'll go ulta. Means don't refer 2008 and all, at least from 2012 onwards. Or some ulta I can go 2020, 19, 18 that way. Prove that dy by dx is t square So first, if you see something is there, what is required here? Only dy by dx. So at least find dy by dx first. This is the parametric differentiation. Find dx upon dt, then find dy by dt. Mention with what you are differentiating. Now it is with respect to t. That's why 3 is anyways coefficient. Minus 1 upon root of 1 minus that x square means t raised to 4 the whole square. into extra derivative of t raised to 4 will be 4t cube. What you will get is minus 12, and keep this like this only, 1 minus t raised to 4 the whole square. Or I can write it as 8 also, but I'll tell you in the next step you will need it. Even if you write 8, no problem. Later again you'll have to write like this one. So this was about x. Same way find y, dy by dt. This is plus for sine inverse and cos it is minus. That's the only difference. Extra derivative of t square will be 2t. So overall answer is 12t upon this. I'll write as t raised to 4. This both powers I want to keep same. That's why I'm doing it. And now find dy by dx. So second answer upon first answer. To have alternate you can cancel. If you reverse, this will go up. So what answer you'll get finally? 1 minus t raised to 4 the whole square upon, there's a t over here. This will go up and get multiplied here. There's a minus sign. So overall it will become minus. I wrote it out here. And this will be 1 minus t raised to 4. If you had got 8 over here, no problem. In the next step, again, you'll have to split that 8 as this way. T raised to 4, the whole square. And now use the formula a square minus b square. Use the formula a square minus b square. So it will be a minus b. B is what? T raised to 4 into a plus b. And one of that will cancel with the denominator. So 1 minus into root into this can be always be separated out. Okay. So one root. I'm not showing you that step. Even though that root of a into b is root a into root b. So this will be your answer. That's your dy by dx. So to prove what is it? D square y, sorry, dy by dx. So take only your left hand side. Substitute the value of dy by dx here. This is 1 second now. T cube is there. Should get cancelled. I'm not sure of the question. I put something wrong with this. It should get cancelled out. Are you all getting dy by dx same? This should be t cube, huh? Make that as t cube. And then you substitute this over here. So t square into, so that's our left hand side. So both this and this will become 0. I've actually done this before also, just check. You know. Something I have done while cancelling. One should have been 4t cube. No one, 1 second. Even the question somewhere. Quickly tell me what was dy by dx upon dt. T cube was there here. This would have been t square. Question is correct. Here I had done mistake. T cube I had forgot to put. I had just put as minus 12. It is minus 12 t cube. So just correct it. Huh? No one corrected. Don't know if you are aware also. And then it will become t square. So your dy by dx is this answer. Okay. Dx upon dt was nothing but this. Dy by dt, t cube it was. And then it will become t square. So question is correct. Okay, there's no t cube. When you substitute, automatically this will get cancelled. This will cancel and this will cancel and become 0. This is the correct answer. Question was correct. I had made a mistake here. Next one. If x is equal to e raised to theta sine theta minus cos theta and y is e raised to theta sine theta plus cos theta, find d square y up theta dx square at theta is equal to pi by 4. Okay, this is a very important question. Please repeat for this while finding d square y upon dx square. So anyway, starting up till finding dy by dx is same method. First find dx upon d theta, then find dy by d theta. So x is this. So we have to differentiate with respect to theta. So dx upon theta. This is u into v rule now. This whole thing is v. E raised to theta into derivative of v. So cos theta and derivative of cos theta is minus sin theta. Minus into minus will become plus. Then v into derivative of u. E raised to theta will remain as e raised to theta only. Then open up the bracket. This term will cancel. We'll get your answer as 2. Now same we find dy upon d theta. How much all are getting? Dy by d theta.
2e theta cos theta.
The same way dy by d theta will be 2 e raised to theta cos theta, because sine plus sine and minus sine will cancel. And then dy by dx will be okay sine theta. So what is the value of this? Dy by dx. So that will be cot theta. Now I need to find d square y upon dx square now. So I'll have to differentiate this again. And with respect to x now, because I want d square y upon dx square. I don't want with respect to theta. Okay. With respect to x now, after getting dy by dx. This is a fixed step to find d square y upon dx square. So now while differentiating, what it will be, we are differentiating with respect to x. So anyways denominator is x, so it will be straight away one more time when we are differentiating, it will be d square y upon dx square. Derivative of cot will be minus cos x square theta, cot theta. But now since this was theta and this is x, this will be with extra. How we used to write dy by dx extra? If this was y, we would have written as dy by dx. But now since this is theta, we have to write this as d theta upon dx. If you forget this, your entire answer will go wrong. So please put a star for this and keep this part. If it was t, this would have been t upon dx. And from where you'll get this value, always I told you, refer here. What you had got, dx upon d theta is your answer. This. So d theta dx will be ulta of this. So it will be 1 upon. So you can put this as 1 over here and keep, and then you can refer this. dx upon that will be 1 upon, and now this is your answer. You can take sign up, or it's okay however you want to keep it as, or cosec you can bring it down. That will become sine square into this. So that's the answer. And at t is equal to pi by 4. So put t as pi by 4, that is 45. So 1 by root 2, the whole cube, 1 upon 2 root 2. That will be your answer. Root 2, sorry. Yeah. Last one, quick. Under this parametric, I'll see if I get time, because next class I want to revise this inverse trigonometry, some problems. So if I finish fast within 1 hour, the remaining half an hour I'll solve this. Okay. If you want me to solve particular problems on this derivatives, I order and all, you can send. I'll solve this. Last one, just in case you all don't attend some of them. If this type problem comes, differentiate log of so whenever they say with respect to another function, the first function you have to always take as u. The second function always take as v. And then differentiate with respect to x. So du upon dx will be 1 log of something is 1 upon that into extra derivative of this. Derivative of sec of x is sec x 10x plus derivative of 10x will be sec square x. You can take out sec of x common. Whole thing is cancelled. So our answer is sec of x. And this answer is derivative of sec x is sec x 10x. And now with respect to x, now don't do second upon first term. With respect to x, mean this will always go to the denominator. So you have to find du upon dv, not dv by du. Huh? First upon second here now. Because with respect to will always go to the denominator. So first, so that will be du upon dx upon dv upon dx. So sec of x upon sec x 10x. Cancel. What you'll get is 1 upon 10x. That will be cot of x will be your answer. That's all which I wanted to tell. With respect to if it is there, it will be u, v, and you have to find du upon dv, not dv by du. And this type, no, the tan inverse with some substitutions might mostly not be there. Still, if you want to confirm, you can ask your teachers, okay? If they have done specifically substitution type, you can just ask once whether they will give this type problems last priority, at least first study those which does not involve inverse trigonometric substitutions and then cancelling out 10 inverse 10 and all. That you give the last priority. Best option is to ask your teachers if those type problems are there. So next class I'll just revise that inverse trigonometry. I'll stop here. And on this you send me problems if you want me to solve. Just take attendance.